Hi everyone, let's continue. So let's continue to example 6. Alright, the first step, we want to compute the homogeneous differential equation. So what is the corresponding characteristic equation? Well, that's r squared plus r is 0. So let's factor it. We can factor the r. Okay, so what are the roots? Well, the roots is r is 0, and here r is minus 1, right? And then the homogeneous solution is, that corresponds to e to the 0x. And then c2 e to the minus x. So 0x, that corresponds to the constant. Okay, so that is our homogeneous solution. So second step, we want to find yp. What's yp? Okay, let's first look at okay. All right. So let's look at the right-hand side of the differential equations. So x cubed, that corresponds, this is a polynomial. Polynomial corresponds to 0. So x cubed is like a multiplicity, corresponds to, the multiplicity is like 4, right? So when you set it up, then so this is the OYP is, okay, you start with the constant term, and then you increase the power. Oops, I put B there. C and then D. Oh, by the way, so when you set it up, you just set up A, B, C, D in general, okay? I see some students like, oh, if they see like 5 x cubed plus 2x, they would put 5d and then 2bx. No, you don't need to do that. D is an arbitrary constant. B is an arbitrary constant. Don't put 2b or 5d, okay? So make it general. So eventually when you solve a b and d, you will see what numbers they are equal to. So you don't need to set up like 2b or 5d. Okay, everybody? So make it general. This is a general term. So x cubed corresponds to multiplicity 4, right? Okay, so we have 4 terms. And this is the OYP. It means we should have a new YP. Okay, that's always the case. So after you do your O setup is just, you look at the right hand side of the differential equation. And then for the new setup, you also need to look at the characteristic equation. Do you see the same roots in the characteristic equation? Yes. If you see the same roots, what do? Your new YP is your old yp multiplied by x to the multiplicity of the corresponding roots in the characteristic equation. So which is 1. Okay, everybody? So that is, let's distribute it. We have ax plus bx squared plus cx cubed plus dx to the 4th. Okay, we still have 4 constants here. So 4 unknowns here. Okay, it's A, B, C, D. I'm a little worried about like students. Sometimes they will say, I have x to the cube. So here we have another roots there. So I should set it up like a maybe a plus bx plus c x squared plus dx cubed plus e x to the 4th. So I have the highest power x to the 4th. No, if you do it like this, you're gonna have 5 constants, 5 unknowns we need to solve. But when you multiply the O set up by the x, you still have 4 constants. Okay, 4 unknowns, A, B, C, D. Okay, so that's why don't do this, because if you say it like this, you will realize when you compare the like terms, there are only 4. There are only like for like terms to compare. You don't have enough information, enough equation to solve the extra unknown. Okay, so don't do this. Okay, so let's continue. All right, so let's continue. What is y prime? So y p prime is a, this is 2bx, this is 3cx squared, this is 4dx cubed. Okay, so I hope every time when you see this example, try to work on it first, and then we can continue and check our answer. And then we also need the second derivative. So derivative of a is 0, then we have 2b, 6cx, 12dx squared. So plug in our differential equation, we get 2b plus 6cx plus 12dx squared plus y prime a plus 2bx plus 3zx squared plus 4dx cubed. What is the right hand side? X cubed. Yes. So another mistake is when students set it up, they only set the highest term. No, you need to contain all the lower terms. Okay, because when you differentiate, the lower terms will appear. Okay, so let's see here. Okay, so let's see here. I ran out of space. Let me create more space. Okay. All right. Sorry that your notes, your bad notes, you cannot get more space from it, but you can write smaller, right? But here I need to show you, so I cannot write smaller. Okay, so let's compare the like terms. Okay, so let's compare the highest power terms. So x cubed. Do we have x cubed on the left? Yes. Oh, so 4d equals to 1. Then d is 1/4. Next, what color do you like? Blue. X squared. We have 12d and 3c, but the no x squared on the right. So we know d, okay, so 3c is negative, 12d is negative, 12 divided by 4 is 3. Oh, c is -1. So far, so good, everybody? And let's continue. What's the next one? Okay, what color? Oh, how about, we haven't tried this before. How about a fancy color? X. So x is this guy, and so 6c plus 2b equals to 0. So 2b is the negative 6c, which is negative 6 times negative 1, 6. Oh, so b is 6/2, 3. So far, so good, everybody? How about the constant term? So the constant term, let's stick with the color. How about green? Okay, so the constant term, we have 2b and a, and no constant term on the right. So a equals to negative 2b, which is negative 6. So far, so good, everybody? Okay, so we figured out our YP, and then what is the general solution? Well, the general solution is our homogeneous solution. And then plus our particular solution. Okay, our particular solution is A is negative 6. X plus b squared, b is 3x squared, plus cx squared, so it's minus x cubed, plus d x to the 1/4. Okay, so this is our general solution of this problem. So far, so good, everybody? Okay, yeah, it's quite long. If the problem gives us initial conditions, then we have to plug in and figure out C1 and C2. The problem will be longer in that case. Okay, so example 7. Let me start with a next page. All right, too much. Okay. Okay, so example 7, find the general solution of this guy. All right, so let's continue. So continue with first step. Oh, the homogeneous part is just y prime prime is 0. So that corresponds to r squared is 0. So we have r is 0 with multiplicity 2. So then the homogeneous solution is C1 e to the 0 is constant plus C2 x. That is our homogeneous part. Okay, in y2, second step, we want to find yp. So we first look at the right-hand side. The right-hand side is polynomial, correspond to r is 0, and this is like the multiplicity is 2, right? So this general setup, okay, the OYP is every time I put OYP, you know there is a new YP. So the YP is, the general setup is A plus BX. Okay, it's like, oh, the highest power is X. So when you set it up, it's the X and the lower term. So you also include the A. Okay, and then, wow, what's the new setup? There's something that this multiplicity, I mean that by looking at this format, it looks like if we follow the rule of the setup, a plus bx is like corresponds to the root r0 and the multiplicity is 2, but this is not the same thing as this. Okay, this multiplicity can be different than 2. Okay, so in order to create confusion, I just erase this. Okay, all right. Next, so we want to have the new yp is then our OYP times x to the multiplicity is 2. Okay, so multiplicity of the corresponding roots is actually 2. So we have ax squared plus bx cubed. You can see here we only have 2 constants. Okay, so don't put like cx plus d there. No. Okay, so we only have 2 unknown to solve. So let's continue. So yp prime is 2ax plus 3bx squared. Yp prime prime is then 2a plus 6bx. Okay, so we're ready to plug in. So we have 2a plus 6bx equals to x plus 5. All right, so let's compare. Let's look at the x terms. So we have 6b equals to 1. B is 1 over 6. So far, so good, everybody. And for the constant term, we have 2a equals to 5. So a is 5 over 2. So far, so good, everybody. Okay, finally, what is our solution? So our solution is, our general solution is the homogeneous solution plus the particular solution is ax squared. So a is 5 over 2 x squared. B is 1 over 6 x cubed. Okay, so this is our solution. Let's continue to the next problem. Okay, so the next problem, actually, I just require you to set up the YP, and you don't need to solve the constants. Okay, so set the YP and don't solve the constants. Okay, so first of all, we still need to figure out our homogeneous solution. So the homogeneous differential equation is this guy. The characteristic equation is r squared plus 4. Don't put 4r here. This is y. This is not y prime. Okay, so what is that? Well, this is actually a complex number. Can you see? It's a plus or minus 2i. So what is the corresponding solution for it? So the real part is 0, so you only have a sine cosine term. So cosine 2x and sine 2x. So far so good, everybody? Okay, and then next you can see here, we have on the right hand side, okay, so we want to set up our particular solution. Okay, so our particular solution here, if we just look at the right hand side, this guy corresponds to r equals to 2 and with multiplicity 1. So this guy corresponds to what? Remember, x cubed is just like repeated. So that will affect the multiplicity, but the roots is actually sine cosine. That corresponds to plus or minus 2i. And if you think about this, this is like multiplicity 1. This is x cubed, so this is like multiplicity 4. So far so good, everybody? Okay, so for our OYP, every time I put OYP, you know there's a new YP. Okay, so the general form corresponds to e to the 2x is a e to the 2x. And the general form corresponds to plus or minus 2i with multiplicity 4. What do? You start with cosine 2x and sine 2x. They always appear as pairs. And then you increase you keep multiplying by x to it. So a, b, c, d, e, f, g. Keep going until you have x cubed. A, B, C, D, E, F, G, H, I. Okay. Yes. That is our O setup. Okay, everybody? Yes. So that's why here, if you see 2 multiplicity 1, you're gonna expect to have one term. Okay? But if you get plus or minus 2i multiplicity 4, that actually corresponds to 8 terms. Okay? Because they appear as pairs and you have 4 pairs. So that corresponds to 8 terms. Okay? Alright, so that's the old setup. What's the new setup? Okay, so the new YP. Okay, so here we actually has 2 roots. For the root 2, you can see 2 is not in here. So that's why we just keep it the same. Okay, so this guy is the same. But plus or minus 2i, you can see this is this guy also appear in the characteristic equation. So we need to increase the power of x. Okay, so all the rest, okay, all the rest, b cosine 2x, c sine 2x, dx cosine 2x, EX sine 2x, F x squared cosine 2x, G x squared sine 2x. Oh, I don't have enough space. So continue. H x cubed cosine 2x, I x cubed sine 2x. And you multiply by x to the multiplicity. What's the multiplicity of the corresponding roots in the characteristic equation? So actually here the multiplicity is 1. It's not 2, it has 2 roots, but the multiplicity is 1. So you only need to multiply by x. Don't multiply by x squared. Okay, everybody? So that's why what is our YP? Our YP is e to the 2x plus. Okay, so we have bx cosine 2x, cx sine 2x, dx squared cosine 2x, ex squared sine 2x, fx cubed cosine 2x, gx cubed sine 2x, and x to the 4th cosine 2x, and I x to the 4th sine 2x. Yes, so that is the setup of our particular solution. Okay, that's why you see this problem just asks you to set up. You don't need to solve the constants. So in the exam, if I ask you to solve the constants, you will see at most 4 constants. Okay, but if I ask you to set up, you might expect you can see more. Okay, but I promise it's not gonna be the whole ABC song. Okay, it won't go to Z. Okay, so far so good, everybody. Okay, I also want to make another problem remark. I just think about that. Okay, so let me create it. Okay, so I have created example 8b. So what is the difference? It's almost the same as the previous one, but you have an extra e to the x over there. Okay, so what would this change to our problem, to our solution? Okay, the first step will be the same as before because your homogeneous differential equation is still the same thing. So that is c1 cosine plus c2 sine. So yh is c1 cosine 2x plus c2 sine 2x. And remember, we have a plus or minus 2i with multiplicity 1 there in the characteristic equation. Okay, so now right-hand side. So when you look at your yp, okay, so second step when you want to find your yp, we look at the right-hand side. So this guy corresponds to r equals to 2 with multiplicity 1. This guy actually corresponds, do you see the extra term e to the x? So it corresponds to 1 plus or minus 2i, and x cubed corresponds to multiplicity 4. So when you set it up, you get a e to the 2x plus, so here you get b e to the x cosine 2x, c e to the x sine 2x, and d x e to the x cosine 2x because it's a repeated root, d e x e to the x sine 2x, b c d e f g h I. Okay, alright, so after you finish that, you realize this guy is not repeated here. Okay, they are different roots. Cosine 2x and sine 2x just correspond to the root plus or minus 2i, but e to the x sine 2x corresponds to the root 1 plus or minus 2i. So they are not the same roots. So that's why this is our YP. This is not all YP. This is actually the YP. Okay, so you don't need to multiply by this guy by x. Okay, everybody? All right, so I just think about maybe we should talk about this. Okay, so example 9. Find the general solution of this differential equation. So let's see here. Let's continue. Okay, so here, same thing, we just want to set it up, okay? So we want to set it up. Okay, just set up the YP. Okay, so the first step, can look at the homogeneous differential equation. So what's the characteristic equation? Oh, do you see this is a complete square? So we get r equals -3 with multiplicity 2. That corresponds to c1 e to the minus 3x plus c2 x e to the minus 3x. So far, so good, everybody? And what's next? Well, we look at our YP. Our YP is, depending on the right-hand side, this guy corresponds to the root -3 plus or minus 5i, right? And what's the multiplicity? Because it's x, then the multiplicity is like 2. And here it corresponds to the root r is 0 and then x cubed, so the multiplicity is like 4. Okay, everybody? So you realize, okay, so when we set it up, the first guy with multiplicity 2, so we start with a e to the -3x cosine 5x, and b e to the -3x sine 5x. And multiplicity 2, so we keep going, cx e to the -3x cosine 5x plus dx e to the -3x sine 5x. Okay, you can see 4 terms. And then the second x cubed, that corresponds to r zeros and multiplicity 4. So you start with the constant term a, b, c, d, e, f, g, h. Okay, so that also corresponds to 4 terms in the general setup of YP. Okay, and then you also want to check, are those roots appear in the characteristic equation? In this case, no. Then this is our good setup. Okay, so this is our answer. We don't need to multiply by a power of x. So far, so good, everybody? So here, don't need to multiply by extra factor of x, because those roots are not appear in the characteristic equation. Okay, so that is example 9. Let's look at example 10. Yeah, we have done a lot of examples in this session, but however, all those examples are second order. So what happens if we have higher order? It's similar steps. We first compute the homogeneous differential equation, okay, and then find the homogeneous solution, and then do the old setup, and then look at the roots. Are those appear in the characteristic equation? If yes, then we multiply by appropriate power of x. Okay, so let's work on this problem. So we first compute the so we compute the homogeneous differential equation. So that the characteristic equation is r cubed plus r squared equal to 0. oh, we can factor completely. So in this problem, we can factor easily, but for higher order ODEs, you remember if we cannot factor easily, you use the rational root theorem. So if it's degree 3, you use the rational root theorem to find one root. And then you use long division to divide that factor and get a quadratic factor. Then you can either factor it or use the quadratic formula to find the remaining 2 roots. If you have a degree 4 polynomial, you use the rational root theorem to find 2 roots. And then you can divide that factor, okay, to get the remaining quadratic factor, and then you can either factor it or use the quadratic formula to find the remaining 2 roots. Okay? Alright, so this is R0 with multiplicity 2. This is R is minus 1 with multiplicity 1. So the homogeneous solution is... So 0 corresponds to the constant terms, so C1 plus C2x and C3e to the minus x. So far so good, everybody? That's the first step. So second step, we want to find yp. So yp, we look at the right-hand side. So this guy corresponds to R is 1 with multiplicity 1. This guy corresponds to polynomial, so correspond to R0 with multiplicity, what? 3. Okay, so the general setup for it is a e to the x, and then the polynomial, so b plus cx plus dx squared. Okay, so this is the setup, and this is the O setup. Because you see 0, 0 is appear here. So this is the O setup. Oh, we know this is O setup. Then we find the new setup. So what is our new setup? Okay, so the first one, 1 is not in the characteristic equation, so we can keep it. And then 0 is 0 in the characteristic equation. Yes, and it's multiplicity 2. So that's why for all these terms that correspond to 0, you're going to multiply by x to the multiplicity of the roots in the characteristic equation. So far, so good, everybody? So then here, this is a good example I want to emphasize. Here, I say multiplicity 3. The 3 corresponds to there are 3 terms. Okay, and here that multiplicity 2 corresponds to you multiply by x to the power of 2. So they kind of have different effects. Okay, everybody? So let's continue. So we multiply out bx squared cx cubed dx to the 4th. And then we differentiate a e to the x. Derivative of that is 2bx. This is 3cx squared. This is 4dx cubed, right? We also need to take the second derivative. For the second derivative, we have still a times e to the x. Here we have 2b. Here we have 6cx. Here we have 12dx squared. Okay, yp cubed is a e to the x. And here derivative 2b is 0. And then we have 6c. And then here we have 24dx. So far, so good, everybody? Okay, your setup is very important. Sometimes if you forget to multiply by the appropriate power of x, you realize some equations is impossible. Like you get like 0 equals to 1. That's impossible. Or if you set up too many constants, you realize after you write out all the equations, there are some constants can be solved. Okay, so that's why the setup is very important. Okay, so let's plug in our differential equation. So y cubed plus y prime prime. Okay, so y cubed is, sorry, this is not y cubed, the third derivative of y. Okay, so that's e to the x, 6c and 24 dx, plus yp prime prime, which is e to the x, 2b, 6c, and 12dx squared. So what is the right hand side? 3e to the x, 4x squared. So 3e to the x and 4x squared. Okay. So far so good, everybody? Yeah, you notice that here we only have 2 terms, but actually we have what? We have 4 constants, 4 unknown constants. Okay, A, B, C, D. Okay, let's continue. So let's compare the like terms. Okay, what color do we use first? How about yellow? We haven't used yellow before. Okay, so let's look at e to the x here, here, and here. So a plus a is 3. Oh, a is 3 over 2. Right? This one is easy. And next, which color do we use? Okay, how about blue? Okay, next, let's look at the highest powers. Okay, x squared. So we have this guy and this guy. So 12v equals 4. Then d is 4 over 12, which is 1/3. Okay, and then we continue. So continue. Which one do we use? Okay, this one. Then we have the x power term. So we have this guy, and no, on the right. So we have 24d plus 6c equal to 0. And we know d. So 6c is negative 24d. So c is negative 4d. d is 1/3. So negative 4/3. So far so good, everybody? And finally, what is our constant term? So we have 6c, 2b is no constant term on the right, so that is 0. So we know c, we're looking for b. So b is negative 6c, so b is negative 3c. So negative 3 times negative 4 over 3, so they cancel. So we have 4. Okay, great. So what is our solution? So C1, homogeneous C1, C2x, and C3 e to the minus x. So our general solution is C1, and then plus C2x plus C3 e to the negative x plus our particular solution. Well, our particular solution is, okay, a e to the x. What's a? 3/2 e to the x. Plus b, what is b? 4x squared. Plus c, or what is c? Negative 4 over 3x cubed. Plus d, what is d? 1/3 x to the 4. Okay, everybody? So this is our final answer of this problem. Okay, so we have higher order, and we first solve the homogeneous differential equation and get a homogeneous solution, and then we set it up the particular solution. Sometimes you might need to multiply by appropriate power of x, and then you differentiate and plug it back into the original differential equations and solve the constants. Okay, and this is our final answer. If you have any questions, feel free to print screen and either email me or ask me during the online office hours. Cheers! Bye, guys!